Hello everyone, welcome back to ML Orbit. In the previous video, we learned about Dunder methods and saw how Python uses special methods like init, str, and repr behind the scenes. Today, we're going to take that idea even further. We're going to make our own custom Python objects behave like built-in lists. We'll learn how functions like len work, how indexing works, and how Python allows us to customize these behaviors using two powerful Dunder methods, len and getItem. By the end of this video, you'll understand how libraries like Pandas, NumPy, PyTorch, and Django make their objects feel like native Python collections. Let's get started. Now, in the previous lesson, we learned that Python syntax often maps directly to Dunder methods. Now, when you create an object user, Python calls init. When you print an object, print obj, Python calls str. And when you use repr to obj, Python calls the repr method. Today, we'll discover that exactly the same thing happens with len object and object index. These operations are also powered by Dunder methods. Now, this might not make much sense right now, but I promise you it will later on. Now, can custom objects behave like lists? Let's imagine we are building a product catalog class. Internally, the catalog stores products. Naturally, users might expect to write len catalog to get the number of products, or catalog an index with 0. This gives the first item's access. Now, these operations work perfectly fine on Python lists. Can we make them work on our own classes? Yes or no? The answer is yes. And the secret is Dunder method. Now, let's get started with the len function. Most beginners think len is special, but behind the scenes, Python is simply calling a Dunder method. When we write len catalog, Python actually executes catalog dot and Dunder method for len. This means that if we define len inside our class, Python automatically knows how to calculate its length. If we don't define it, Python raises an error because it has no idea what length means for our custom object. Now, let's switch to code. Alright, here, like we previously mentioned, we'll be implementing a product catalog class. Product catalog. And we define our constructor def init. Self. And we go self.products is equals to, and we define a list with, say, laptop, mouse, and a keyboard. Alright, so this is our list, and now let's define a len function, which is supposed to be a Dunder method. Now self again. Now return len self dot products. Alright, now let's understand what's happening here. Inside the class, we're storing products in a regular Python list. Now, when Python calls catalog dot, when Python calls catalog dot double underscore len double underscore, our method simply returns the length of that internal list. Notice that we aren't restricted to using a list. In production systems, developers often calculate lengths from database records or API responses or files or even cache entries. The important thing is that the Dunder method len must return an integer. Now, let's see this. Let me remove this. Let's create an object, product catalog, and print len catalog. Alright, now let's run this. Let me open my terminal and let's type python main.py. As you can see, 3 has been printed here. Our custom object now supports len just like any other native Python list. Now, let's compare the behavior. Without len, how would this function? Now, let me remove this len function, or like comment it out. If I save this and run this again, we get an error. Now, but with len implemented, we would get this. Now, we've taught Python how to measure our object. this is exactly how Dunder methods work. We provide the behavior and Python provides the syntax. Now, let's talk about indexing. Now, when you write, say, catalog and index it, it looks like Python is directly accessing the object, but that's not what's happening here. Behind the scene, Python executes. Let me give an arrow, catalog dot double underscore get item double underscore and passes 0. Alright, now that we know that this is what happens behind the scenes, we can say that the index value is passed directly into the Dunder method. So if we define get item, we can control exactly what happens when someone uses square brackets on our objects. Now let's implement this again. Now let me remove this and let me make this smaller. Now let's define, let me keep this, let me remove this. Let's uncomment the len method, and let's implement our own get item. Get item double underscore self, and we pass an index for the index to be returned. Now we return self dot products on square brackets, we write index. Now let's test this. Now we already have our catalog object. If we go down and say we go print catalog 0, let me pull this up, let me clear this, and let me type python main.py. We get 3 and we get laptop, which is the first element of this list. Now that's pretty cool. Now our custom object now supports indexing exactly like a Python list, but there's something even more interesting here. Now let's try a loop. Let's try a for loop. Now if we go say for product in catalog and we simply print product, let's run this. We get all our elements printed. Now notice that we never implemented a loop method. Python automatically uses get item to support iteration. This is one reason why so many professional Python libraries implement this method. Now, you might be wondering where this is actually used in the real world. The answer is everywhere. Pandas data frames support indexing and length operations. NumPy arrays behave like collections because they implement these kind of Dunder methods. PyTorch datasets use len and get item on a regular basis, so training loops can work automatically. Django query sets behave like lists for the same reason. Experienced Python developers often design classes so they feel natural to use. Instead of forcing users to call catalog.getProduct and index 0 again, they can simply write catalog big square brackets in 0 so that it feels more cleaner and natural. Now, this was a quick video, and let's quickly recap what we've learned today. Now, when we write len obj, what's actually being called is obj dot double underscore len double underscore. Now when we write obj square bracket index, we're actually calling get item. Now, by implementing these Dunder methods, custom classes can behave like built-in Python collections. This makes APIs cleaner, easier to use, and more intuitive. And it's also a technique used heavily throughout the Python ecosystem. In the next video, we'll continue exploring Dunder methods and learn how operator overloading works using add, or the Dunder function add. We'll see how Python powers expressions like a plus b behind the scenes. If you found this video useful, please make sure to like the video, subscribe to the channel, and leave a comment telling me which Dunder method you'd like to explore next. Thanks for watching, and I'll see you in the next one.